Okay, so today we're diving into something that really jumped out at me from the research you shared. It's about marine pollution, but maybe not the kind you immediately picture.
Right. Not the plastic bags or, the big oil slicks we often see images of.
Exactly. This is more hidden, invisible even. We're talking about the silent threat of toxic metals and how they're impacting, well, some really beloved marine animals, dolphins.
Mm-hmm.
So for this deep dive, we're looking at some recent studies from Brazil, Scotland, the Mediterranean, quite a spread.
Yeah, good range.
And our mission really is to unpack how these unseen contaminants are affecting dolphins, especially the vulnerable ones, and what that tells us about the bigger picture, the health of our oceans overall.
And what's really fascinating, I think, is how these studies use marine mammals, dolphins in particular, as these crucial sentinels.
Sentinels, how so?
Well, they give us this unique window, a critical lens, into the health of the whole marine ecosystem. They show us patterns, especially with these invisible pollutants, that we'd probably just miss otherwise.
That's a really important point.
Yeah.
Because like we said, you think pollution, you think visible stuff. Garbage patches, oil.
The obvious things.
Right. But these sources, they point out that coastal areas are basically the final repository for all sorts of chemical contaminants, stuff washing off from cities, industry, farms.
And it doesn't just stay there, does it?
Exactly. It can spread, move right up the food chain. It becomes, well, pervasive.
Which is precisely why dolphins and marine mammals generally are such good bioindicators, as the science calls them.
Bioindicators. Okay, break that down. Why dolphins specifically?
Well, think about it. One, they're often top predators, right? At the peak of the food chain.
So they eat things that have already accumulated contaminant.
Exactly. Two, they live a long time. So they show us exposure over years, decades even, not just a snapshot.
No.
Three, they're pretty sensitive to changes in their environment. So they can be like an early warning system.
Yeah, an early warning.
Right. And many species live near coasts, close to human activity, making them directly vulnerable. And the key thing is, their bodies bioaccumulate these contaminants, heavy metals, metalloids they build up in their tissues over their lifetime.
So they're literally carrying a record of the pollution around them. If they're the sentinels, what does that signal back to us? Is there a connection to our own health?
Oh, absolutely. The studies really emphasize this one health idea.
One health.
Yeah, the concept that the health of the oceans, the marine life, it's all inextricably linked, as they put it, to human health on a global scale.
So if dolphins are being impacted,
especially dolphins in areas where people fish, then yeah, there are definite implications for human communities relying on those same marine resources. It reflects back on us.
it's a direct mirror.
Okay.
And these studies, they looked at quite a variety of dolphins, didn't they?
They did. On the Brazilian coast near São Paulo, they focused on Guiana dolphins.
Which are near threatened, I remember reading.
That's right. And Franciscana dolphins, which are even worse off, vulnerable or critically endangered in places.
Right.
Then over in the Mediterranean, off Sicily, they looked at striped dolphins and common dolphins.
Okay.
And up in Scotland, the focus was on harbor porpoises.
Mm.
So yeah, it gives us a pretty broad, almost global snapshot of this hidden issue.
Now here's where, for me, it got really interesting. The Brazilian study.
Yeah.
It found something truly eye-opening about how early this pollution exposure can start.
Ah, you're talking about the transplacental transfer.
Exactly. Can you explain that? It sounds serious.
It is. They found direct evidence, actual proof that these toxic metals pass from the mother dolphin right across the placenta to her unborn calf.
Before it's even born, it's being exposed.
Precisely. Exposure in the womb.
Yeah.
And what's maybe even more startling is that for some metals, like vanadium and copper, the levels were actually higher in the fetus than in the mother herself.
Oh, higher. How does that happen?
Well, we'll get into potential mechanisms, but yeah, higher. So that unborn calf is getting this concentrated dose, this sort of metal cocktail, before it even breathes air.
That's deeply concerning. The study listed copper, zinc, arsenic, vanadium, mercury, all found in the fetus of a Franciscana dolphin.
And the vanadium finding was particularly surprising. It's not something researchers often report finding in marine mammals.
Why is that significant?
Well, if you look at human health studies, prenatal exposure to vanadium has been linked to things like lower birth weight, preterm delivery.
Oh, wow.
So finding it in a dolphin fetus, it suggests this whole potential risk pathway in marine food webs that we just haven't really explored before.
And the consequences for the calves themselves must be huge, starting life already exposed.
Immense. The sources point out that these metals, present so early, can mess with fundamental things, enzyme systems, how neurons develop.
So neurological problems, issues with their immune system, maybe growth.
Exactly. Compromised development right from the start. It can lead to higher death rates for the calves, lower overall fitness throughout their lives. It casts a really long shadow.
And you mentioned a detail about copper and zinc. Something about active transport.
Yes, that was fascinating. In the fetal liver, copper and zinc levels were roughly 5 times higher than in the mother's liver,
5 times.
which strongly suggests it's not just passive diffusion. It implies the placenta is actively pulling these elements across to the fetus, which is, well, a key piece of the puzzle.
Okay, so exposure starts before birth. But the studies also looked at how these toxins build up over a dolphin's whole life, right? What did they find about how age or sex makes a difference, or even where in the body the metals end up?
Yeah, there are definite patterns. The Brazilian study showed what they called progressive bioaccumulation. Basically, as the dolphins got older, they had higher average levels of things like cadmium, mercury, molybdenum.
So it builds up over time.
It does, and the Scottish study on porpoises found the same thing. Age-related buildup of mercury, bismuth, cadmium, selenium, silver, vanadium. Adults consistently had much higher levels in their liver than the younger ones.
Okay, that makes intuitive sense. The longer you live, the more you accumulate. But what about males versus females? Any differences there?
That's where the Mediterranean study gave some interesting insights. They generally found the highest levels of certain toxic metals in females.
Really? Why would that be?
Well, a couple of potential reasons were suggested. Females tend to have more fatty tissue, more adipose tissue, and that's often where these kinds of foreign chemicals, xenobiotics, get stored.
Ah, okay. Like a storage depot.
Sort of, and there might also be differences in hormones, or maybe males have enzymes that are just a bit better at breaking down and excreting these toxins.
Interesting. So biology plays a big role in where this stuff goes. And you mentioned location, not just male or female, but specific organs too.
Absolutely. Different organs handle things differently. The liver, no surprise, is a major site for accumulating most metals. It's the body's main processing and detox center, after all. But then you have exceptions. Cadmium, for instance, seems to really favor the kidney. That's where it tends to be most concentrated.
Okay.
And they also found that skin and lung, which maybe aren't studied as often for this, could be really interesting. They might show more about recent acute exposure.
Whereas organs like the liver, muscle, kidney, they tell a story of chronic long-term exposure, probably through diet.
Exactly. Which brings us back to food being the main highway for these contaminants and top predators.
It's that biomagnification idea again, right? Working its way up the food chain.
Precisely. And the levels can get incredibly high. The sources mentioned mercury levels in marine mammals can be, get this, 10 to 100 times higher than in the predatory fish they eat.
100 times. That's staggering. Why such a huge jump?
It seems their bodies just aren't as efficient at detoxifying and getting rid of it compared to fish. It builds up much more dramatically.
Wow. Okay. And geographically, was it just a case of more pollution near cities means higher levels in the dolphins?
You'd think so, but it was a bit more nuanced, actually. The Brazilian study had a surprising finding there. Overall, they didn't necessarily find higher contaminant levels in dolphins from the really densely populated areas. It suggests that maybe ocean currents spread some of these pollutants out quite widely.
Huh. So it's not always just about the immediate vicinity.
Not always. However, there was one clear exception: cadmium. Levels spiked in Guiana dolphins, specifically in the industrialized southern part of the study area.
And they linked that.
Yeah, it was consistent with runoff from local phosphate fertilizer industries. So while some stuff spreads out, other pollutants have very clear, localized hotspots tied to specific human activities.
Right. Okay. So we got this complex picture, invisible metals, starting before birth, building up differently based on age, sex, organ. But what happens when the dolphins' bodies try to cope? You mentioned mercury being a big one found across studies.
Yes, mercury, or Hg, consistently showed up as the most abundant toxic metal, especially in the liver and skin. And this leads to the challenge of detoxification.
How do they even try to detoxify something like mercury?
Well, their bodies do have some natural defenses. Essential elements like selenium C and zinc, Zn, can actually play a role in binding to mercury and making it less harmful.
Ah, okay, so they have some tools.
They do, but the question is, are those tools enough? The Mediterranean study looked at this by calculating molar ratios, basically comparing the amount of selenium to mercury and zinc to mercury.
And what do those ratios show?
Well, generally the ratios were less than 1,
Meaning?
meaning there wasn't enough selenium or zinc relative to the amount of mercury to provide full protection. The essential elements were, as the study put it, insufficient to exercise a protective action against Hg toxicity.
So essentially, their detoxification system was overwhelmed by the amount of mercury they were carrying.
That's what the ratios strongly suggest, yes. For most tissues studied, there was one exception in the kidney of the common dolphin, but overall, the picture wasn't great.
That sounds pretty grim. But didn't that same study also use a metal pollution index, an MPI?
Yeah.
That showed something different.
It did, and this is where it gets complex. Despite those high mercury levels and the concerning molar ratios, the overall MPI values across all tissues were actually below 1.
Which is considered safe.
It's considered within safety levels, yes. And the researchers suggested this might reflect improvements in marine pollution levels in recent decades, perhaps thanks to new European regulations.
So it's a mixed message. The overall environmental score looks okay according to this index, but the internal biological battle against specific toxins like mercury is still being lost.
That's a good way to put it. It's nuanced. The index gives a broad overview, but the molar ratios reveal a specific ongoing toxic burden and struggle within the animals themselves.
Okay, so pulling this all together,
Yeah.
what does this mean? For us, for the oceans, where do we go from here?
Well, first, it absolutely hammers home how vital these dolphins are as sentinel species, finding these metals in fetuses. One source called it not just a conservation red flag, but a potential indicator of broader ecosystem disruption.
They really are those early warning signals.
They absolutely are. They're showing us the impacts of things we can't even see. It's critical information for regulators, for policymakers.
And the studies themselves, they call for specific actions, don't they?
Yes. Things like stricter catch limits for the endangered Franciscana dolphins, which get caught accidentally in fishing gear. Also, targeting cleanup efforts at those known industrial pollution sources, like the ones contributing cadmium.
Right, the hot spots.
And importantly, more research. We need to understand how these different metals interact together and how that combines with other stresses. Dolphins face warming oceans, noise from ships, lack of food. It's really just one thing.
It's the combination of stressors.
Okay.
So let's try and recap the key takeaways from this deep dive. We started with the idea of pollution being invisible, these toxic metals.
Moving beyond just the plastics and oil.
Then the really shocking discovery of prenatal exposure toxins passing from mother to calf before birth.
Yeah, the transplacental transfer. A huge finding.
And we explored how these metals build up over time, differently in males and females, and in specific organs like the liver and kidney.
The complex patterns of bioaccumulation.
And finally, the struggle dolphins face trying to detoxify these metals, especially mercury, even with natural defenses like selenium and zinc, which seem to be overwhelmed.
The molar ratio is telling that story.
It paints a pretty sobering picture.
It does. And it leaves you thinking, you know, if these invisible threats are already compromising the very start of life for some of the ocean's top predators, what are the unseen ripple effects?
Right. What does that mean for the whole food web?
Exactly. And what does it demand from us in terms of vigilance, in terms of action, going far beyond just cleaning up the pollution we can physically